And remember, mean or expected values, those are not actually numbers. We will never find 3.5 people. It's just what we would expect. All right. Number 12. Over here we have a survey for brand recognition is done, and it's determined that 68% of the consumers have heard of Dell Computer Company. Okay, 68%. What is that? When you see a percentage, you're going to say what kind of distribution? Binomial, right? Do we have a fixed number of trials? Yes, 800. N is 800. Do we have, what is our probability of success? Yes, and then one person is independent from another, and the probability stays the same from person to person. Okay, in order to figure out if something is an unusual number, we're going to use the mu minus 2 sigma and the mu plus 2 sigma. That was one way to find unusual values. Another one would be looking at probabilities. If a probability is less than 0.05, that would also be considered unusual. Okay, so to find the mean, we are going to do n times p, just like in the previous example. And so what is our mean?
5.44.
Okay, standard deviation is the square root of n times p times q, so that's 800 times 0.68 times 0.32, just 1 minus p again. And what is that? And you can round it to a whole number. 13. Okay, now we're going to find the minimum usual value and the maximum usual value. So minimum usual value is the mu minus 2 times 13. And then the maximum usual value is the mean plus 2 times the standard deviation. So can you guys calculate both of those? So I have 518 for the minimum and 570 for the maximum. So we would expect between 518 and 570 people. So is it unusual to get 607? Yes, because it's greater than the maximum. Yes, question.
How did you do 0.32?
So Q is 1 minus P. So 1 minus 0.68. I always make those two add up to 1. All right. Number 13. This is shaded areas 0.8599. So we're now going from the binomial to our normal distribution. When you have a normal distribution, you're either going to have a curve drawn, or it's going to specifically say it's normally distributed. This one has a standard normal distribution, which has a mean of 0 and a standard deviation of 1. You can use the table in order to find this, but it's going to be easier to use the normal CDF or the inverse norm. So in this example, we have a shaded area given. So you always want to draw in your area. Put the number right next to your shaded area. So both the table as well as the calculator always uses area to the left. So what do you do when the area to the right is given? Yes, so we do 1 minus to find the area to the left. So that's 0.1401. Okay, that's the area to the left. Now we can either use the table, look at the center of our table and find the value that's associated, or we can use what? So this time we have area given, we're trying to find values down here. We use the inverse norm when we have area given. Inverse norm, area to the left, standard deviation, mean is 0 and the standard deviation is 1. Okay, so inverse norm. So going to second vars to our distribution. Inverse norm, make sure you enter in the area to the left, not the right, and then enter in your mean and your standard deviation. And you end up with a negative z-score, which is negative 1.08, rounded to 2 decimals. Z-score is always rounded to 2 decimals, probabilities rounded to 4. And then you check your graph. You know, it's standard normal, which means it's symmetric. 0 is right in the middle. The left values are going to be negative, and this one definitely makes sense when I look at it. If you had put in this area to the right, it actually would have given you the symmetric one on the right. So just by looking at your graph and understanding, oh, I should end up with a negative score, you can make adjustments. And that only works, though, for the standard normal, which is the one that's symmetric. All right, number 14. Assume that X has a normal distribution and find the indicated probability. The mean is 15.2 and the standard deviation is 0.9. So this one is a normal distribution, it tells us, but it's not standard normal. So we're going to label our mean in the middle. Always draw your curve. Write down your standard deviation. Find the probability that X is greater than 17. Does 17 go to the right or to the left? Okay, greater than 17, do I shade to the right or left? Okay, I have X values given. I'm trying to find probability or percentage or area. What do I use? It's the normal CDF. What do I enter as my lower value? What do I enter as my upper? Very large number. And then I enter in my mean and my standard deviation. Okay, when you calculate that, is 0.0228. That gives you an area underneath the curve. You know, from your table, it looks like it's a fairly small area. So again, check your answers, right? It's less than half of your graph is shaded, so it should correspond to a probability, you know, which is pretty small. All right, so we will have time probably not to go over everything, but at least, you know, 1 or 2 more questions over here. Okay, in a population of 210 women, the heights of women are normally distributed with a mean of 64.9 inches and a standard deviation of 3.2 inches. If 49 women are selected at random, find the mean, mu x bar, and the standard deviation of the population of sample means. Assume that the sample is done without replacement and use a finite population correction factor. We didn't really talk about the finite population correction, so I'm going to take out that part, and we're just going to calculate the mean and the standard deviation. So the answers are going to be slightly different than the answer options here. So what is the mean of our sample mean? So what is mu of x bar? Yes, it's the same as the population mean. What is the standard deviation of the x bar? And then? That is the population standard deviation, but we're looking at 49 people, and we're looking at the mean of the 49.
Divided by the square root of 49.
Yes, this is the central limit theorem. So 3.2 divided by 7. So let's find that answer. And again, it's going to be slightly different than the choices because we didn't talk about that finite population corrections. Yes, 0.4. Let's just round it to 2 decimals. 0.46.